Hi, and welcome to the 10 square meter workshop. Those of you who follow my channel will know that I recently converted my drill mill machine into a 3-phase variable speed device. This went very well, and I decided to do the same thing to my lathe. The belts are easy to change on this, but it's still not as good as having full variable speed. I wasn't going to make a video on this because it seemed the same thing all over again, but there was enough differences that it may well be of interest to someone doing the same task. These 3-phase inverters with variable speed come in a variety of flavours. Not just the voltage out and the power they can handle, but in the number of features they have. I chose the unit for my lathe because it had a small display panel which could be removed on a ribbon cable and located elsewhere. However, it's not until you buy the unit and open the often very poorly translated instruction book do you discover exactly what features your particular unit has. The unit for my milling machine had the very useful feature of being calibratable so that the speed is displayed on the front panel in RPM. The unit I bought for my lathe sadly does not have that feature. But what it doesn't do is show the speed when it's stationary. In other words, the speed it will attain when you switch it on. With my milling machine, I used a latching switch already there to turn my machine on and off. My lathe also has reverse, so it uses this 3-way latching switch to do this. It is, however, a rather large and ugly, and I could use that space for the display. My answer to both these problems was an Arduino Nano microcontroller. These are remarkably cheap, £3 or £4 on Amazon or eBay. I coupled this to an 8-digit LED display from my spares box. Using a microcontroller means you can solve both of these problems. Firstly, the switch, latching and logic can all be handled by the micro, and also you can measure the intended speed from the potentiometer on the front and the actual speed by measuring the analog output from the control unit. The only place for the inverter was on the wall behind the lathe, so I wanted the actual controls mounted on the lathe itself. I 3D printed a box to fit the space and mounted the components into it. A printed back includes cable clamps. This was mounted into the space the switch used to occupy. The whole unit fits where the switches used to go. This also contains an isolator for the whole unit. This is just a latching switch, not an NVR, but the unit itself does that job. When powered up it all starts stopped, as it were. When powered on, after a couple of seconds you get the display showing the dialed in speed. You can adjust this to whatever speed you want, and when you start the unit it measures the actual speed. The lathe sounds very loud on video. This is not really the case. It's an effect of the microphone being auto level setting. It's actually much quieter than it used to be. Whereas the VFD shows the frequency that it's sending to the motor. Just over 33 Hz in this case. The Arduino is very easy to program, especially if you've done some coding in the past. This whole project has ended up being a lot bigger than I first intended, but it's been quite enjoyable sorting out all the various problems. I hope there's some points in there that may be of interest to you, and if you're doing a similar project. That's all for this time. Bye!